Welcome back. This is an Aleks training video on identifying acids and bases by their chemical formula. So the chemical formula will sometimes give you a lot of information that you could use to make a determination of whether something's an acid or a base. If you remember, you're looking many times for ionic or molecular compounds. You have ionic bonds whenever you have something that's a metal joining with a nonmetal. So something on the left side of the periodic table joining with something on the right side. Molecular compounds are often metal or nonmetals joined with other nonmetals. And remember, hydrogen is also a nonmetal. So water would be molecular. Table salt would be ionic for that reason. Now, if there is a hydrogen to give, and often it will be listed first on your compound. Many times acids are written so that you see the hydrogens first. Then you can tell that it's an acid. If you remember when we learned how to name or how to write the formula for compounds, hydrogen did not come until right before groups 6 and 7. So everything before it would come first on the formula, then hydrogen, then group 6 or 7. The exception to that is when there's an acid. If you have an acid, often your hydrogen is listed first on your compound, which really makes it useful because if you see a hydrogen sticking out there, especially sticking out there at the beginning, you can many times believe that it is an acid. A base is a little bit harder because a base is a receiver of a hydrogen. The easiest base to determine is a strong base, and a strong base often is a hydroxide. If you have an OH hydroxide and it joins with a hydrogen, you'll get water. And lots of times hydroxides will neutralize the base with an acid and make water as one of its compounds, one of its products. So with that, we can make some guesses here. So let's look at the first one. I've got HClO3, okay, HClO3, so this is chlorate, and I have an H. This is an acid, okay? And if you remember, 8 goes to ic. This is chloric acid. So I've got an acid here. Is it ionic or molecular? Well, this is a nonmetal, this is a nonmetal, this is a nonmetal, so these are all molecular bonds. Okay, so what about the next one? Potassium hydroxide. Well, hydroxide is -1, it's a polyatomic ion, so it's an anion. Potassium is in group 1, that's a cation, so it's ionic because there's ions involved. There's a polyatomic ion and a group 1 ion, so this is a metal and a non-metal anion, so this is ionic. Okay. Can it receive an H? Well, it's an OH. It's a strong base, so it's gonna if it attracts a hydrogen, then you're going to have 2 hydrogens and an oxygen. If it kicks out the potassium, you'll have water. So yes, this is a base. Anything hydroxide is going to be a base. The next one here is H2SO4. Sulfate, if you remember, is a polyatomic ion, -2 charge. I've got 2 hydrogens in front, so this is an acid. In fact, this is called a diprotic acid because there's 2 hydrogens, not just one. It doesn't just have 1 proton to give, which is a hydrogen, but it gives 2 protons, so it's diprotic. So this is definitely an acid because it has H's to give. And remember, 8 goes to ic, so this is sulfuric acid from sulfate. Okay. Is it a molecular or ionic bond? Well, hydrogen is nonmetal, sulfur's nonmetal, oxygen's nonmetal, so these are all molecular. Okay. What about the last one, potassium bromide? Potassium is a group 1 metal, bromine is a group 7 nonmetal, that's a metal with a nonmetal, that's an ionic bond. Does it have an H to give? No, it's not an acid here. Does it have an OH to receive an acid or to receive a proton? No. Does it mean it's not acidic or basic? No, it doesn't. We're just basically looking at easy examples. So for right now, I'm not going to put acid or base. I have no way of determining from just this information yet. Okay, so just keep chugging.